One of the deliverables of this project was a camera trap simulator. The purpose of the camera trap simulator is to primarily be used in the testing and prototyping of cloud solutions involving camera traps. Camera traps can be difficult to get a hold of and take time to connect and integrate into a cloud system. This is often before even knowing if the camera trap is a suitable device to be used within a cloud solution. The simulator allows users to quickly set up and test how a camera trap would integrate and work within their solution. To explain further how the simulator works, I'll be using this diagram. On the left we have two boxes, one green and one blue. Each box contains two options, one of which must be chosen. In the blue box you can choose to use a live camera feed for the simulator to operate on. When I demo it, I'll be using my laptop's webcam, but you could also use something such as a camera module on a Raspberry Pi. The other option is to use a recorded video feed. This would be something like an MP4 or MPEG file. This second option is likely the better option as it allows you to more closely simulate the environment that the camera trap would be working in. For example, it's rather difficult for me in the south of England to use a live camera feed for simulating elephant detection. A better option would be to use a pre-recorded video of an elephant conservation area from an area such as Zambezi for the simulator to operate over. The green box also provides two options to choose from. The first option is to use motion-based detection. This means that the camera trap will be triggered when it detects movement in the video feed. The other option is to use a machine learning model. This option will run frames from the video feed against a machine learning model which you will have to supply, and it will check to see if the model gives a positive result, indicating something of interest was detected. This version is likely to be more useful as it will give significantly less false positives and focus only on the things of interest to the user. These options end up allowing for four combinations of how to run the camera trap simulator. If the user does not have a video to use or a machine learning model ready, they can still use the simulator with a live camera feed and a motion-based option. These types of users are likely to be using the simulator to decide if a camera trap is a good fit for their cloud solution. If a user already has a video and a machine learning model ready, they can use a simulator with those options. These users are likely to have already decided on using a camera trap in their solution and would be using the simulator to more accurately simulate data coming in from the camera trap, either due to not having access to a real one or simply just for convenience. At the top of the diagram, you can see a yellow box. This represents the config file. This allows you to easily fine-tune certain parameters to fit your needs. The object size parameter is only applicable to the motion detection option and is the size in pixels of the object you want to detect. If you want to detect larger or smaller objects moving in the image, you would increase or decrease this parameter respectively. The reference frame reset parameter is also only for the motion detection option. This parameter refers to how frequently the reference frame is reset. The way the motion detector works is it will take a frame and use it as the reference frame. The subsequent frames will then be compared to this frame. If there are any significant differences exceeding the object size, then we say the current frame is sufficiently different from the reference frame and class it as seeing something having moved and motion being detected. This reference frame is reset every set number of frames. If you wanted it to reset once per second and had a 30 FPS video feed, you would set this value to 30. The mock geo position asks you to provide a longitude and latitude you want to simulate this data coming from. It allows you to work with geo tools once the data is in the cloud, such as Azure Maps. The model check rate is only applicable if the machine learning option is chosen. It is how frequently a frame is taken from the video feed and run against the model. If you wanted to use the model once per second and had a video feed with 30 FPS, you would set this value to 30. All of these options feed into the main loop of the program, where the program constantly checks to see if the camera trap simulator has been triggered, either due to motion detection or the machine learning model, and if not, continues looping and makes the same check. If it has been triggered, then it will send a notification to Azure IoT Hub saying that something was detected. Once this data is in IoT Hub, it can be put in storage, analyzed, or cause other events to be triggered. It is up to those using the simulator what solutions they want to create with it. Okay, so I'm going to start off the demonstration for the camera trap simulator, making use of motion-based detection with a live video feed. So you can see four boxes have popped up on screen. The bottom right box is just the normal camera feed. The top left box is the normal camera feed that's been grayscaled and had a Gaussian blur applied to it. This is done simply to make the image processing a bit easier to do. The bottom left box is the difference between the current frame and the reference frame. And then the top right box is the threshold. So if the difference between the current and a reference frame is significant enough, then the top right box will show where that significant enough difference is, where the motion is being detected. So if I just put my hand into the frame now, you can see it being detected. If I start moving it, it's still being detected. If I keep the hand still, due to there not being much motion, it's not really being detected. If I start moving it again. And if we take a look at the messages sent to Azure IoT Hub, you can see here that it's sending a GeoJSON format, and that's sending the coordinates or the longitude and latitude of the simulated position for the data being sent. It allows you to work with kind of geo tools in the cloud, such as Azure Maps. You can see here we also have an animal tag that's been left blank. That's because obviously with motion-based detection, you can't identify what it is that's moving, you just know that something has moved. So you'll see when we move on to machine learning based models that this tag will start to be filled in. Another option that we have is motion-based detection with a pre-recorded video. So I have a video set up here in which we want to identify a little man walking across the street. So let me run that. And this is still using motion-based detection. Alright, and you can see as he walked across the street, that motion was detected and messages were sent to IoT Hub. Again, we still use the same format, with the GeoJSON and then the animal tag, which is left blank for now. What's a more interesting way of using the simulator is making use of a machine learning model. So if instead of a -v tag, we had a -n. And if I run this, what it's going to do now is instead of using motion-based detection, it will use a machine learning model that I trained beforehand to detect animals and among them elephants. Right, so the areas on screen are just complaining I'm not using a GPU when I could do, but on screen you can see there's two boxes now. This is a live video feed, so that's me. And on the right, this is the image seen by the machine learning model. So I think once per second, it's going to take an image from the live camera feed and give it to the machine learning model. Now, this model is looking for elephants, which I don't really have many of, but I have a picture of one. So hopefully when I put this picture up to the camera, you'll see messages on the command prompt saying elephant was detected and messages sent successfully to IoT Hub. And yes, I think it is sending data. Yep. So if I exit from this, and you can see here it's sending the GeoJSON data as before with the simulated longitude latitude, but now it's also filling in the animal tag saying it's detected an elephant. We can also combine both the machine learning model and a pre-recorded video feed. So if I provide a model and I also provide a pre-recorded video, so I've got a video here of elephants called Elephant and before we run this. Yes, you can see here on the left we've got a big picture of a video feed of some elephants, and then on the right is the image seen by the machine learning model. And you can see here as it's seeing elephants on screen, messages are being sent to Azure IoT Hub. What you may have noticed is that there are some frames where there's an elephant clearly in the picture for us that the machine learning model wasn't able to detect. That's because my machine learning model requires the image to be resized to 256 by 256. And when resizing a large image down to that size, it can cause the elephant in the image to be kind of quite small and not be detected by the model. This is further discussed and kind of improved upon when I talk about the machine learning model deliverables in another video. But for now, that was the camera trap simulator.